Hi everyone, welcome to my channel, and in this video we are going to discuss the problem: is this priority or parity from the Starters41 contest from CodeChef. Now in this problem we are given n integers ranging from 1 to n, including 1 and n, it's both in a clockwise fashion. Now what do we mean by clockwise fashion is, let's say n is equals to 6 and the integers are then 1 2 3 4 5 6 because they are ranging from 1 to n, and clockwise fashion would denote that 1 points to 2, 2 points to 3, 3 points to 4, 4 points to 5, 5 points to 6, and after 6 there is not an end to the array. 6 again points to 1, 6 again points to 1 because this array goes in a clockwise fashion. Now after this, once we have understood what in clockwise fashion is, there is one more input that we are given is k. K denotes the kth place of of an integer from the smallest integer in the array. Now what do we mean by that is, let's say we have n equals to 6 and k is equals to 4. So the smallest integer of the array is 1, and the kth place from the smallest integer in the array would be, now let's say this is the first place from 1, this is the second place from 1, this is the third place from 1, this is the fourth place from 1. So fourth integer from the smallest integer 1 is 4. Now why we are taking like this, not like this, so 2 is the first 2 is the first integer from 1, 3 is the second integer from 1, and 4 is the third integer from 1, and 5 is the fourth integer from 1, because in the question we are given that if we should include 1 also, the kth integer starting from 1. So we should always include the smallest integer 2 while calculating the kth place. So that makes this assumption wrong. So always while calculating the kth place integer from the smallest integer in the array, we would also include the smallest integer's place, which makes 1 the first, 2 the second, 3 the third, 4 the fourth. Now once we are clear with this, let's come back to the problem. Now there is a boy Ashish. He likes to remove the kth place integer from the array repeatedly. He repeatedly removes the kth place integer from the array until only one integer remains in the array. Now we have to tell the parity of the integer that remains after these kth place removals, repeated removals. Now what do we mean by that is, let's say n is equals to 6 and k is equals to 4. Now we have to remove the fourth place integer from the array again and again until we are only left with one integer in the array. So now the smallest integer in the array is 1, and the fourth place integer from 1 is 4. So that makes us remove 4. Now the smallest integer again in the array is 1, so and the fourth place integer is 5, so that makes us remove 5. Now and again we remove 6. Now the smallest integer in the array again is 1. Now how do we find the fourth place integer, because we have no integer after 3. Now in that case we know that the array is in circular fashion, so 3 would point to 1. So if 1 is the first place integer, 2 is the second place integer, 3 is the third place integer, that automatically makes 1 again the fourth place integer from 1. So now we have to remove 1 only. So after removing 1, we are left with 2 and 3. Similarly, when we look for the kth place integer from 2, because now 2 is the smallest integer in the array. So now 2 is the first integer from 2, 3 is the second integer from 2, and 2 is again the third integer from 2. Now since this is in circular fashion, and 3 is again the fourth place integer from 2. Now after this will make sure that 3 gets removed. Now we are left with 2. Now this is a case how we would make removals happen. Now let's divide our sub problem into a smaller problems, like into smaller cases, like when for different kind of values of n and k, when n is odd and when is k is even or odd, that would come to our mind for basically for the cases. So let's take the case 1 when n is even, case 2 when n is odd. These can be further divided into k when k is even, k is odd, k is even, k is odd. Now for let's take first n is equals to even. Now for that let's take n is equal to 6. Now let's take a even value of k, let's say 4. For that we have already found out that the integer that remains is in the last is 2 and 2 has even parity from above. We already found it here. Now let's take a different case. Now let's say n equals to 6 but k equals to 3. Now what should we do in that case? When k is equals to 3, now 3 is the third place integer from 1, so that makes us remove 3 because this is the first integer. 1 is the first integer from 1, 2 is the second integer from 1, and 3 is the third integer from 1, and 1 is the smallest integer in the array, so that makes us remove 3. Now 4 is the third place integer from the smallest integer in the array. Now that makes us remove 4. Now again we remove 5 because 5 is the third place number. Now again we remove 6. Now what about these two? Now for this we would do is, what we would do is that since 1 is the, these are in clockwise fashion, these are in clockwise fashion, so that makes 1 the first integer from 1, 2 the second integer from 1. Now again 2 points to 1, 1 is the end after 2, you can say. So 1 is again the third integer from 1, so that makes us remove 1. So we are left with again 2, and this number is also even. So we can say when n is even, so irrespective of k, we would always get a even number in the last after the removals as a single element remaining in the array. Now let's go to case 2 when n is odd. What would happen in this? Let's assume n is equals to 7 and k is equals to, let's say again 4. Now if we take 7, now the array would become 1 2 3 4 5 6 7 including 7 as it is given in the question. Now 4 is the fourth place integer from 1. Now I hope here is no doubt about why is 4 the fourth place integer from 1. So that would make us remove 4. Fifth is the fourth place integer from 1. That would make us remove 5. 6 is the fourth place integer from 1. That would make us remove 6. 7 is the fourth place integer from 1. So that would make us remove 7. Now for 1, 2 and 3, what we would do is, these are all in clockwise fashion. So what we would do is, since 1 is the first place integer from 1, 2 is the second place integer from 1, 3 is the third place integer from 1, and 1 is again the fourth place integer from 1. So we would remove 1. So we have got 2 and 3. Now for these two are again in clockwise fashion. 2 is the first place integer from 1, 3 is the second place integer from 1. Now again 3 points to 2, so 2 becomes the third place integer from 1. And now 2 points to 3, so 3 becomes fourth place integer from 1, and we remove 3. Now we are getting now after this 2. Now this is a number with even parity. Now let's take another case when n is equals to odd and k is also equals to odd. Let's say n equals to 7 and k equals to 5. Now what would happen in this case? 1, 2, 3, 4, 5, 6, 7. 5 is the fifth place integer from 1. So we remove 5 and we are left with 1, 2, 3, 4, 6, 7. 6 is the fifth place integer from 1. So we remove 6. 1, 2, 3, 4, 7. Now 7 is the fifth place integer from 1. So we remove 7. 1, 2, 3, 4. Now we don't have fifth place number now. What we would do? Just write them in a clockwise fashion. We would always get the answer automatically. 1. Now 1 is the first place integer from 1. So that makes 1 is the first place integer from 1. Now 2 is the second place integer from 1. 3 is the third place integer from 1. 4 is the fourth place integer from 1. Now since 4 is pointing to 1, so 1 again becomes fifth place integer from 1 only. So now we remove 1. So now we are remaining with 2, 3, 4. Now again we draw them in a clockwise fashion. 2 is the smallest integer in the array now. Now since 2 is the smallest integer in the array, now 2 is again the first place integer from 2. 3 is the second place integer from 2. Fourth is the third place integer from 2. Now 2 again becomes fourth place integer from 2 since it is in clockwise fashion, and 3 becomes the fifth place integer from 2. So we remove 3. Now we are remaining with 2 and 4. Now we can say, since we are remaining with only even numbers, we can surely say, but still we would do for the sake of clarity, that since 2 is the first place integer from 1, as 4 is the second place integer from 2. Now 2 is again the third place integer from 2. 4 is the fourth place integer from 2 because they are going in clockwise fashion, and 2 is again fifth place integer from 2. So that makes us remove 2 and we are left with 4. 4 is a number with even parity. So that makes us have an even number. So we see when n is odd, irrespective of k, whether k is odd or even, we always get a number with even parity. So we can say that whether n is even or odd, we would always get a number remaining in the last with even parity. But that is not true completely, because in some cases our logic would fail. Now let me show you those cases. There are very small cases where the value of k is small, which makes our code fail. Now let's say k is equals to 1. What we would do in this case, let's assume the array is 1, 2, 3, 4, 5, 6 for n is equals to 6. Now 1 is the first place integer from 1 itself, so we remove 1. So we are left with 2, 3, 4, 5, 6. Now 2 is the first place integer from 2 itself, and 2 is the smallest integer in the array, so we remove 2. Now 3 is the first place integer from 3 itself, so remove 3. Now similar fashion, we remove 4, we remove 5, so we are left with 6. Now this is a number with even parity. Now let's wait a minute. Let's say if n was 7, n was odd, we could automatically say that after the removal of 6 we would be left with 7, and 7 is a number with odd parity. So depending on the value of n, for the first time after these many cases, we are getting a number with odd parity in remaining at the last. So depending on the value of n, whether n is odd or even, when k is equals to 1, the parity of the number remaining at the last t of the number remaining at last after repeated removals is same as parity of n. This is true. Now what? Now there is one more case which is similar to k is equals to 1 case, because since we are taking the first place integer from 1, now k is equals to 2 can also play an important role, because this also takes the next integer from the smallest integer itself. Now what do we mean by that is, let's say k is equal to 2 and n equals to 7. So now for this case, the second place integer from 1 is 2, so that makes us remove 2. Sorry, let's just remove it. Yeah, 1 3 4 5 6 7. Now the second place integer from 1 is 3, and 1 is the smallest integer in the array, so that makes us remove 3 until we remove all in between slowly, and again we remove 7 too, and we are left with 1. So in this case, whether n is equals to, if n was even also, let's say 8 also, then also we would always be left with 1 only. Sorry, this here it would come 8. So we would left with 1 only. So we can say when k is equals to 2 or k is equals to 2, we always get the number with odd parity. And for the now we are clear upon what cases we have. Now the cases we have are when k is equals to 1 and k is equals to 2 and k is greater than 2. For the bigger numbers, I think we have handled all the cases when n is even, when n is odd. We have handled all the cases, and in all the cases we are getting a number with even parity. For k is equals to 2, we always get a number with odd parity. For k equals to n, it depends on the parity of n. As the parity of n is same as the parity of the number, we would get at last. Now we are clear with our cases, and now we can code freely without any doubt in our mind, because I think there are no more cases which are left to take care of. Now let's move on to the code, how you proceed with the code. First we would make a scanner here. I'm using Java from here for my coding, but if you are using someone who uses C++, you would also understand this. I am making sure for you, because the logic is pretty same for all the languages. So first we take input of the text cases. We are given that we have to do this. We have to find the parity for n t-test cases. Now while we have taken the input of t, until t becomes 0, we will take the input of the test cases, input of the numbers, I mean. So I have taken into input n, I have taken into input k, and I have taken both. So now I will put the condition, my conditions. If k equals to 1, now what would happen is we would print in C++. I know you use cout and C. System.out.println is similar to cout only. I know you don't be confused with this, because system.out.println is similar to what is cout. So we would print depending upon if n is odd, then we would print odd, and if n is even, we would print even. That was what we found with our test cases. Else if k is equals to 2, then this is a test case where we would always get a odd value in the last. Now upon to the final case. Now besides these two test cases, we have taken larger values of k, and for all n equals to, if whether n was even, whether n was odd, we were always getting a number with even parity. So for rest of the test cases, we can simply say that we would get a number with even parity. And after this, one thing to note here is that in this question we are told to take very large outputs like these. So for the sake of this, we am changing the outputs of n and k to long, so that we don't face trouble while we pass our test cases. So we would take our output in long instead of integers, so that would facilitate our size issue and correct it. So we have made some mistakes while doing this. Okay, we have not written this condition correctly. Let's just, yeah, there had to be a question mark. I was in a hurry. This is a conditional statement. Let me write it clearly if you don't know how this conditional statement works for you guys. This is a conditional statement, just a replacement of if else, but I will write correctly later. If n mod 2 is not equals to 0, we'll just print odd, else we print even. So now let's run it and let's see if there is any error in our program. No, I assume that there is no error in the program because it doesn't look like that. Everything seems to be fine. Yeah, everything seems to be fine. Let's run it. Yeah, we got our answer. Now it got successfully executed for the sample case. Even, even, odd, even. Now let's try to submit it. It is running. My internet is quite slow, so we just have to wait. Yeah, our submission got accepted for all the test cases. So we have passed all the test cases, so that means that our solution was right. So this this passes. So that's the solution for the problem. If this video helped you in any way, if is so please make sure to like and comment on the video and subscribe to my channel so that it provides some sort of support and I would say a little bit motivation to continue to upload such kind of videos. So till then, goodbye.